Okay, greetings everyone. Welcome to Trigonometry for Students and Surveyors. We're Lesson 8. Lesson 8 is a continuation of Lesson 7. We are using the same triangle. We're just going to go into more detail and solve all the different sides and angles on the whiteboard here. Before I kind of just ran through them roughly with my calculator, showing you the way to store. So these are prior, the first few lessons were all right triangles, and we tried to hit those every which way we could, and had a few examples. We measured a tree, we measured a creek crossing, a river crossing, showed you other different ways to use those. They're very handy. I mean, they're almost indispensable. These are oblique triangles, non-right triangles. So the way to solve those is formulas. You got to memorize the formula. You got to write them down and have a cheat sheet, unless you do enough of them over and over and over again that you can get them memorized in your head, which is probably a lot of people can do that. I'm not very good at doing that, so I have my formulas. And here's the same formulas that we had. Now we're going to go with the law of sines, and this particular iteration is going to be side, angle, angle. Law of sines, we're going to go, so we're going to have one side and two angles known. Of course, I've got everything filled in here now, so that's not an issue here, but here's your formula. So this would be the side A right here. So you want the sine of A, so that you take the sine of that angle, and then you'd want, pick any two you want, but they got to match it. They got to be a pair. So here we're using B and sine B. So you'd have side B, 132.1782, divided by the sine of B, which is here, 61. Let me just grab my calculator, make sure that's all working out. So 61, sine is 8746, that's correct. So you divide that by that and multiply it times that. So 132.1782, 1782, enter 0.8746, 0.8746, divide 151.1299. I got 1265. This is a decimal thing. You're going to get, when you get into your tenths, hundreds, thousandths, and 10,000ths, it's going to be a decimal thing. And then now we're going to multiply that times the sine of A, sine of the angle A. So 5878. Oops. That should be 0.5878. Times 888341. Got a little bit different here. It's just a decimal thing. We could work that out again. I would have to just store everything. That's why I like to store things in my keys here, because it carries a decimal. I showed you guys earlier how to hit show. Let's see if that comes in. If you see where it carries a decimal way out. So that's a decimal thing. So now we've solved for that length over here, 888299, by using this formula here. Now here's the thing to keep in mind, just like a right triangle, you can solve angle A by using the sine, the cosine, or the tangent, depends on what you have known. Same with this one. We could have done the same thing. The sine of A, you start with the same sine of A, but then you use C and sine C as a pair. C and sine C. Oh, the word C, there it is, sine C, because they're always opposite each other. And so whatever, if you didn't have that information, you have that, you can use that. You're going to come up with the exact same answer. So we could actually do that real quickly. A36, we're going to go sine, and I'm just going to hit enter. Now we're going to go, sine is C over sine C, so C is 150. We're going to go enter. Sine C is 83. Sine is 9925. So we're going to hit divide. 151, 1265, and then hit times. 88, 8299. So that's solving it both ways. Then the other ones are just all the same thing. We're just doing it. You can solve each one by, it depends on what you have. Sine B, if you're looking for B, sine B, A over sine A, sine, or B, the side B, sine B, again, those are the same, those don't change. Just these two pairings change. So C, same thing, and you can just see on the board here, I worked them all out. So B is a sine of B, so we'll work that one out. We'll go 61 sine, and now we just pick a couple here. We're going to go, looks like we used A, so we'll go 88, 8299. Enter, and now we want the sine of A, 36, sine, divide is 151, 1265, sounds familiar, and then times. 132, 1782. We just solved for B. That's how we do that. So it's mainly these formulas. They're up here and they're here. Take a screenshot or find them in a book. My only problem with finding some things in the book is they don't really explain. They use sort of a cryptic mathematical language that's like, what do they mean by that? And I'm going to show you when we flip this over to the other side, and we're going to do another set of triangles with another set of law of sines. But we're going to start solving for angles rather than distances. Here we've been solving for distances. You could also solve for angles. You just rearrange these patterns and these pairs, and we're going to do that on the other side. So only thing we haven't done, let's do sine C is the same thing, is A over sine A or B over sine B. We can do that one too real quick. So we want to solve for the line, we want to solve for C, which is 150. We already know the answer, but we're going to solve for that. We'll go A over A. So we want sine, we want C, so we want to start out with the opposite of that. So 83, and the sine is 9925. That's right there. And now we're going to go with, looks like here I went with B, so let's just go with B. 132, 1782. 0.1782. Enter. And the sine of B is 61. And then the sine of that, and now divide. That's division. That's what this is division. 151, 1265, and then times. And then we get 150. 150, 0. So there we've solved it. A, 1, 2, and 3, A, B, and C. And that's really, at the beginning here I talked about your materials, graph paper, scale, protractor. Take these formulas, get your graph paper, your pencil, your protractor, and draw some triangles, and then work through these, and you'll start to see these patterns develop. And you'll, so it's always, you know, this the angle and the opposite of that, and there's different ways to do it, but there's different side angle, side angle. We're going to get into all of those, but you'll start to see these patterns, and the more you do them, the more these patterns will jump out at you. The better off you'll have, better chance you'll have to remember, put that in your memory. So that's that, and that side angle, and what we solved was for the distances. We could also solve for the angles, but we're going to do that on the other side, just slightly different, tweak it just a little bit different. Okay, we're still in lesson 8, and we're doing the law of sines. And so here's our new triangle. We have side or angle A, side A, angle B, side B, angle C, side C. This is going to throw us a little bit different here. One of the things to remember, the way we're doing it now, we're doing side, what are we doing? We're doing SSA, side, side, angle. The other one we did angle, angle, or side, angle, angle. We're doing side, side, angle. To solve this, you need to get going on this one. You need a side opposite an angle. And if you don't have this side opposite this angle here, or one, you need to do that. You need to do that by going into the law of cosines first to solve this. If you have this but don't have that, you have to go in the law of cosines to do that. We're going to do that on the next lesson. We're going to go into that. If you recall on my lesson, I believe 4, when I did the tree, we measured the tree. I used 2 right angles. And then to check it, I used the law of cosines to combine those angles and use an oblique triangle and measure it. And we got a good check on that. So that's what we're going to do. And then we're kind of getting through all this stuff pretty good. So we're going to go now over here with law of sines, side angle requires side opposite the angle. Yeah, to get started on, you got to have at least one on the opposite side of an angle. You have to have a side. So we're going to start with sine A. These are your formulas here. Sine A, this is how it's written, and this is why I say the books can be a little bit confusing. So we're looking for angle A right over here. That's what that means. So to get that, you use the side A over sine C. Now remember, this can also be different angles, different. Just like on the other side, we could use 2 different pairings to come up with our side. Here we can use 2 different pairings to come up with our angle. So let me grab my calculator. I pretty much got it all worked out here. So what we're looking for is angle A. That's what we're looking for right here. Now they write it in the book, they just call it sine A. And that was confusing to me for a while because I just couldn't come up with the answer until I tried arc sine. What they're really looking for is arc sine. We're trying to get the angle, and you got to get that by arc sine. So to do that, you take the opposite. Again, remember, these things always go in pair. We're taking the opposite, which is A, over the sine C. Now the reason we're using this, because this is all we had to start with, is this angle and that distance. If we didn't have the opposite, like here, we don't have the opposite to that angle, and we don't have the opposite to this angle. You got to start somewhere. And if you have a measurement here, you have that angle and that measurement, then you can calculate this one with the law of cosines. So we have the side A times the sine of C. Like I say, we're using C because that's what's available to us, over the opposite of C, which is that distance. Okay, sine C, 147, and the sine of C would be 96.59. So let me just pop that in and make sure we got that right. So C is 105, and we want the sine is 96.59. So 96.59 is the sine, so we have 147 times the sine of C, and that becomes 141.91. Then we just carry this 251.8825 over there. Now we divide those, obviously. And then we want the 140, so we add those, or 141.9659, 147 times 0.9659 gives us that. We drop that over there, and we divide that. 141.911. 251.8825 divide 5637, 5634, whatever you have there. Now you want the arc sine of that. And arc sine. 3429.14, 3429, 3134. This is about carrying decimals, which I didn't load them all up into here. Actually, on this one I did. I know I've gone over this with you before on these calculators, but on this one, if you hit store or recall, you can hit A, B, C, D. So I use this one, A for angle A, B for angle B, and C for angle C. I skip this line because this recall doesn't give you a chance to store anything there. So you skip the line, I go down to the next line, and that line is side A, side B, and side C. Makes it very easy. So we can do sine of A, well, let's just do that. The sine of, well, we don't have sine of, that's what we're looking for. A, so I'm gonna go recall A, that's that one down there is 147. And what are we doing there? We're looking at the sine of 105, which is C, so recall C, sine, and then times 141, 9911. And now that's my side C, so I'll just recall C and then hit divide. And that's 5637. And now I want the arc sine of that. Yes, I want the arc sine of that. 34, 31, 34. So that's what that is. And then if you want to convert that to hours, minutes, seconds, 34, 18, 48. I have 48 here, I wrote 38. Okay. So that's how we do that one. So let's solve for angle B now. So now we have two angles with two opposite sides. So we don't have to use C, we could use this one the next time, which is why I have it written over here twice. We now have two angles with the opposites. So let's solve for B. Now remember, it says sine B, but you need the arc sine when you're all done. When you get that decimal, or when you get that percentage, you need to use the arc sine, not the sine. Okay, now we want sine B. We're going to go for B. That's the big capital uppercase B. So we want B. And we can take sine C, or we can take the other one. We'll take sine C. So we're going to go, the opposite of B is 170. So we're going to go recall, I'm going to have that under B is 170, all right. And then I want sine of C, so 105. So recall C, and then I want the sine of that. And I think I want to times that. Times 164,2047. Well, I got 74. I think that's a very common thing with surveyors, is juxtaposing numbers. 4774. It's just, I don't know why, but it's very easy to do that. And now we want to divide the side opposite C. So that's going to go recall 251.825 divide, and I got 0.65119. That's that ratio. Now we want to do arc sine. 40, 68, 66. And then we'll convert that. 40, 41, 12. So we've got all our distances and all our angles there. So now let's use sine. We'll use B again. We're going to solve for B. Now I'm going to show you that you can use a different angle. You can use the other angle as well. So it's going to be the same thing. We're going to go B is the sine of A. We're going to use A this time. So B 170 is right there. So we're going to go recall my distance is B, 170. Then I'm going to recall A. That's the angle, 34, 31, 33. And we're going to go sine. And we're going to go times. And now we want the distance, 147 divide. So that is angle A. So I just recall A, hit divide. 0.6519. Same as that there. Same as that there. So arc sine 40, 68, 65. We're 1 second off. Somehow we got a second off. So remember, there's 3,600 seconds in 1 degree. So it's a decimal thing. You're going to run into that back and forth. A lot of times in the books, that's why they just stick to degrees, and you'll see the numbers that they round them. They would drop those off. They just drop those off. So, and that's that. Now we're going to go to sine C. We're going to go C is a little different. 105. So this is an obtuse angle. And I showed you yesterday or last lesson, obtuse is an angle greater than 90 degrees. An acute angle is less than 90 degrees. A 90-degree angle is a right angle. So now we're going to go and do this one is a little different. Not much different. It's just one more step. Sine C. So we're trying to get this angle here. We don't know what that is. We don't know that that's 105. So we're going to take C again. Then we just pick one of these. Let's see. It looks like we picked out B. So we're going to go recall C is 251.8825. And now we're going to recall B, which is 40.6866. And we're going to take the sine of that. And we're going to times that. And now we're going to divide by 251. Oh no, the opposite of B, sorry, 170. So recall B and divide 9659. Okay, so that's 0.9659, which is right here. Okay, now here's where it gets tricky. So that's, if I hit arc sine, I get 75.0002. Well, that's not 75.002. The way you come up with that is now just subtract it from 180 because it's an obtuse angle. Just minus 180. So 180 minus, I got 104.9998, which is 105 with a 2. In fact, we converted over. I got 104.5959, so 1 second from 105. So that's the only thing, if you have an obtuse angle like that, and you're trying to solve this, one thing you don't really have to, because you can always add these up, subtract from 180 to get that. But if you ever do try to solve for that obtuse angle and you can't come up with the answer, subtract 180 from it, and then you'll get your answer. And I think, so next time we're going to do law of cosines and a few more angles. We're going to do side, side, side. When you have all three distances, all three sides, but you don't have any angles, we will do that. There's no such thing as angle, angle, angle. That's because it can expand, contract, and the angles are going to stay the same. And then we're going to do the law of cosines, and we're going to do a few more of those, and then that should wrap up our oblique triangles. And then we'll move on to one of my favorites, is coordinate geometry. I think we'll have a lot of fun doing that. And that's all for today. So these formulas, sine A is right. So A times the sine of C over C, B times the sine of C over C. Write these down, look them up, get a cheat sheet. get your graph paper out and do these over and over until they become memory. It's kind of fun. You can draw your angles, check them with your protractor, check them with your scale. Remember to rotate your scale and keep it on the right scale. That'll mess you up. And that's all for lesson 8. And please like and subscribe.